So imagine for a second the ultimate learning fantasy. You probably know the exact one I'm talking about.
Oh, yeah. Matrix style.
Exactly. You sit down in a chair, you plug in, and you just instantly download the ability to perform a wildly complex real-world skill. Zero risk, zero friction.
Right, like learning Kung Fu in 5 seconds.
Yeah, exactly. Or, if you want to learn how to completely tear down and rebuild a multi-million-dollar industrial turbine, done. You know every single bolt.
You're an instant expert.
Right. Or say you want to practice a really delicate, high-stakes medical procedure in this perfect risk-free simulation until your hands just know the movements by pure muscle memory. Easy.
It's the dream, really.
It is. We've all dreamed of that exact scenario. Just this idea that you could step into a digital room, master reality, and completely eliminate the time it takes to become competent at something.
Yeah, and I mean, it really is the ultimate goal of education and workforce development, right?
Yeah.
The promise of completely bridging that gap between theoretical knowledge and actual hands-on operational readiness. Just, shrinking that time to competency down to almost nothing.
Exactly. But if you've been following the tech space, or honestly, even if you just look around your own workplace when a new hire starts.
It's a mess.
Right.
Yeah.
We aren't quite living in that science fiction future yet. So today's deep dive is exploring exactly why that is, and more importantly, the massive structural breakthrough that dropped literally today, March 31st, 2026.
Yeah, this is huge news.
It is. We are looking at a major press release and the accompanying white paper from EON Reality and EONAI Ventures. They just launched the EON Genesis 2.0 3D library.
And, looking through the architecture of this release, this is, well, it's not just an incremental software update.
Not at all.
It is a fundamental rewiring of how immersive training is created, validated, and deployed at a global scale.
So we are going to explore how a brand new library-first approach is solving the massive bottleneck that's been holding immersive training back for years. And we're going to highlight the incredible, tangible benefits this brings to you, whether you're an enterprise executive managing thousands of employees or just someone trying to learn a complex skill.
Absolutely.
Okay, let's unpack this. Because to really understand why Genesis 2.0 is such a massive leap forward, we have to look at the reality of the industry up until this morning.
Right.
We have to understand why mastering reality takes so much time in the first place.
Yeah, because in theory, immersive training has always been a phenomenal idea.
Sure.
The data has always shown that when professionals practice in realistic virtual environments with lifelike equipment, knowledge retention just skyrockets.
Oh, yeah. It goes up, yeah.
Learning cycles are dramatically faster. Workplace performance improves because, well, people aren't just reading manuals, right? They're actually doing the action.
Exactly.
But the reality of actually deploying those simulations has been, to put it mildly, surprisingly clunky.
Right. I mean, if the adoption of virtual and augmented reality is bottlenecked by cost and time, then we have to look at how these things are actually built.
Yeah.
I think a lot of people listening might wonder, if VR is so great for training, why isn't it just the standard everywhere? Why doesn't every manufacturing plant or hospital just have a headset in the break room for onboarding?
Right. And the reason is that adoption has been severely limited by structural inefficiencies in how the content itself is created. Meaning we are talking about traditional simulation-based training being plagued by an incredibly labor-intensive process. Building just one realistic 3D environment, say a simulated factory floor or a specialized hospital operating room, currently costs tens of thousands of dollars.
And tens of thousands for one room.
Oh, easily. And it requires weeks, sometimes even months, of highly specialized 3D artist labor.
That's crazy. It's like hiring a massive Hollywood visual effects studio to custom build an intricate physical movie set every single time you want to train a single employee on a new piece of machinery.
That is exactly what it's like.
You hire the carpenters, the painters, the lighting crew, they build this incredible room, you train one guy how to calibrate a specific valve, and then what? You just spent $50,000 and waited 2 months for one lesson. It's totally unsustainable.
It really is.
But wait, I have to push back a little here. Let's say a developer builds that hospital room or that valve. It's digital, right? Can't they just copy-paste it for the next client? Why hasn't that solved the cost issue?
It's a great question, and it really gets to the heart of the problem. That is exactly where the old model breaks down.
Okay.
The industry has historically operated on this really ad hoc, bespoke basis. So content was built specifically as single use.
Oh, I see.
Yeah.
Mm.
When a developer built that hospital room for Hospital A, they hard-coded the physics, the interactions, the lighting, and the texturing for one very specific context on one specific hardware platform for one specific use case.
Wow. So it was essentially locked in.
Completely locked in.
So it isn't like a standard computer file you can just like email to someone else?
Not at all. A simulation developed for Hospital A couldn't be easily transferred or reused or extended by Hospital B, even if Hospital B used the exact same medical equipment.
That is wild.
The underlying code was entirely custom. Every time a new training program was needed, the animations, the interactive components, the environments, they were all being built from scratch all over again.
Yeah.
You were essentially paying master craftsmen to hand carve a brand new hammer every single time you needed to drive a nail.
That sounds incredibly frustrating. You're just burning time and money repeating the exact same labor.
Precisely. And if we connect this to the bigger picture, industries today are evolving incredibly fast.
Oh, for sure.
Think about renewable energy or advanced logistics or modern healthcare. New equipment, new technologies, and new operating processes are being introduced constantly.
Yeah, it's nonstop.
A wind turbine manufacturer might update the design of their stator every 6 months to improve efficiency. This slow, custom-built, artisanal training model simply cannot keep up.
It's just too slow.
Right. The speed of industrial innovation has completely outpaced the ability to train people on those innovations.
Which means companies are stuck. They either pay a fortune and wait months for a custom virtual training module that might literally be outdated by the time the developer finishes it,
Exactly.
or they just resort to giving people a dense 400-page PDF manual, putting them on the factory floor and hoping for the best,
Which is terrifying.
which is a huge liability, both for safety and for productivity. So if the bespoke model is wasting all of our time, the only way to scale is to stop treating every training module like a custom piece of art.
Yes.
And here's where it gets really interesting. Because EON Genesis 2.0 is fundamentally a transition from that bespoke, custom-built model to a centralized, library-first infrastructure.
The shift to a centralized, reusable library is the core innovation here.
Yeah.
It completely replaces that ad hoc process we just discussed.
And the numbers they dropped today are just massive. They aren't launching with a small proof of concept just to, test the waters.
No, this is a massive rollout.
Right. This initial release features 95 fully photorealistic environments. And on top of that, there are 475 interactive 3D objects right out of the gate.
Which is an incredible starting point.
It really is. And they are spanning 19 different industry verticals. The release specifically highlights energy, defense, manufacturing, healthcare, logistics, and education. That is a massive footprint on day one.
It is, and I want to highlight why covering those specific verticals matters so much.
Okay, yeah.
The primary benefit of this library-first approach is something that acts as reusable training capital.
Reusable training capital.
Yes, this is a fundamental shift in how organizations approach their training budgets and their timelines. Instead of a one-off operational expense where you throw money into a black hole to get a single locked-in simulation, organizations now have an asset class.
Okay, let's make that concrete for the listener. How does reusable training capital actually work across, say, defense and healthcare? Because those seem like entirely different worlds.
They are different worlds, but they share foundational needs. Let's say the library contains a highly detailed, interactive 3D model of a portable defibrillator.
Okay.
In the old model, the military would pay to develop a simulation for a field medic using that defibrillator in a combat zone. A hospital would pay completely separately to develop a simulation for a surgeon using that exact same defibrillator in an ER.
Right. Two massive budgets, two long timelines.
Exactly. But with reusable training capital, the defibrillator is already in the Genesis 2.0 library. It is a standardized, quality-gated asset.
Oh, I see.
The military drops it into a desert environment. The hospital drops it into an ER environment. They both have instant access to the exact same high-fidelity training object.
That is so efficient.
Right. They can instantly deploy these pre-validated assets or combine them to build whatever they need whenever they need it. It shifts the entire economic model of immersive learning from building to assembling.
It is just incredibly smart. You are assembling reality from pre-made, perfect pieces instead of like molding it from clay every single time. And I know you were looking closely at the validation side of those pieces.
Oh, absolutely. The quality validation framework detailed in the architecture is it is spectacular.
Huh. I love how excited you get about validation gates.
I can't help it. It's brilliant. You see, When you are building a centralized library that spans 19 verticals, the standardization process has to be rigorous.
Sure.
If everyone is pulling from the same library, the assets have to be flawless. They've implemented these strict quality gates to ensure that every single asset, whether it's a massive industrial forklift or a tiny surgical scalpel, meets exacting operational realism standards.
Okay, wow.
The polygon count, the texture fidelity, the dimensional accuracy, it all passes through this incredible gauntlet of validation before it ever reaches the user.
Let me stop you there because I want to make sure we're grounding those technical terms. When you say texture fidelity or dimensional accuracy, my mind instantly goes to a high-end video game.
Right, sure.
Like, we want it to look pretty, but in this context, we aren't talking about graphics just for the sake of aesthetics.
Not at all. And I'm so glad you brought that up. It guarantees that the training is empirically accurate, which is literally a matter of operational safety.
Safety.
Okay. Texture fidelity and dimensional accuracy aren't about making a game look pretty. If a simulated medical valve in the headset is even 2 millimeters off its real-world counterpart, or the digital texture doesn't accurately reflect the visual wear and tear of metal fatigue.
Oh, wow.
Right. The muscle memory the surgeon or the engineer develops is not just useless, it's dangerous.
Because they're learning the wrong feeling.
Exactly. They might pull too hard in the real world or miss a visual cue that a part is failing. If the simulation isn't mathematically and physically accurate, you aren't training, you are just playing a game. The rigor matters.
That makes total sense. The visual data is actually safety data. So having established what this massive library is and why the assets are so meticulously validated, we have to talk about how it actually functions for the learner.
Definitely.
Because a beautifully validated, perfectly measured static 3D model still isn't enough, right? Scene composition is great, but it has to be a functional training tool.
Exactly. And that is where the concept of component-aware equipment comes into play within these environments.
Component aware.
Yes. The 95 operational spaces, the data centers, the defense installations, the construction sites, they provide the hyper-realistic context. But the 475 interactive objects are where the real operational learning happens, because they are component aware.
So what does this all mean for the person actually putting on the headset? Break down component aware for me.
Sure.
Because if I'm playing a normal video game and I see a highly detailed car engine, it looks great. But if I hit it with the virtual wrench, it just clangs. It's essentially an empty chocolate bunny.
Chocolate bunny.
Yeah. It's a hollow shell painted to look like an engine. Are these objects different?
They are fundamentally different. A standard 3D model is exactly as you described, a hollow, single-mesh shell. Component-aware models, though, are built more like digital Legos.
Okay, Legos.
Every single part is individual, with its own physics boundaries, its own metadata, and its own relationship to the whole. Because they are component-aware, they aren't solid digital blocks. You can entirely break them down.
Oh, wow.
You can grab a virtual wrench and physically disassemble a complex industrial motor piece by piece. You can unscrew the housing, remove the stator, interact with the dials on a medical device, and the simulation understands the mechanical relationship between all those parts.
So it actually understands how the machine works, not just how it looks.
Precisely. But it goes even further than just simulating the physics, through a process the architecture calls knowledge injection.
Now this to me is where the whole concept goes from a great 3D tool to a true learning revolution. Because we are talking about accelerating that time to competency, these assets aren't just physically accurate shapes, they are smart. They come embedded with standard operating procedures, or SOPs.
What's fascinating here is that the knowledge is literally baked directly into the digital asset.
Baked in.
Right. In the old way of doing things, you might have a great VR simulation, but the trainee still had to read a separate manual or pull up a floating two-dimensional menu screen in the headset to figure out what to do next.
Which is super distracting.
Extremely. With knowledge injection, the training annotations, the step-by-step procedural guidance, the safety warnings, it is all embedded in the 3D object itself.
It turns the digital object into an active participant in the learning process. It's like if you bought a piece of incredibly complicated IKEA furniture, and instead of staring at a confusing paper manual with those little cartoon drawings, the wooden planks literally glowed in your hands and whispered, "I connect to part B using this specific screw," when you pick them up.
That is a perfect analogy. You are interacting with the equipment exactly as you would in the real world, but the equipment is effectively coaching you through the SOPs in real time.
That is incredible.
Imagine you are in the VR headset looking at a high-pressure valve on an oil rig. Because of knowledge injection, the valve itself can highlight the exact bolt you need to loosen first with a green outline.
Wow.
It can project a floating, real-time warning about the pressure gauge right next to your hand. It guides both the instructors who are assembling the lesson and the learners who are executing it completely intuitively.
This entirely eliminates the friction of translating text on a page into physical action, which is usually where mistakes happen.
Exactly.
You read step 4, you look down at the machine, and you guess which lever step 4 meant. Here, the machine is telling you, which is huge for safety and compliance.
It's a game changer.
But, okay, let me play devil's advocate for a second. Let's say a major enterprise is completely sold on this. The chief learning officer sees the Genesis 2.0 library and says, we want this. They want the smart assets. They want the reusable training capital. They want the validated component-aware library. The final hurdle to widespread adoption is always the IT department, right? How easily can an organization actually integrate and scale this? Because nobody wants to tell their CFO that they have to buy 10,000 entirely new, specific VR headsets just to use a new software library.
That is the brilliant part of the deployment strategy, and really why the library-first model is so potent. Genesis 2.0 is specifically designed using industry-standard formats.
Meaning it seamlessly integrates into an organization's existing VR and AR ecosystems.
Exactly.
It is hardware agnostic. You do not have to throw out the headsets you already have. You don't have to rebuild your learning management system from scratch.
Nope.
It plugs right into what an enterprise is already doing, adapting to meet specific operational needs while preserving all that validated quality we talked about.
It is entirely plug-and-play. And that plug-and-play capability is paired with something that completely future-proofs the entire platform. This is how they plan to beat the clock of industrial innovation moving forward.
Yeah.
The batch generation pipeline.
Yes, because 475 objects and 95 environments is amazing for day one. But as we said, industries evolve fast.
Very fast.
So when I hear the term batch generation, I instantly worry about a drop in quality. Like, if you automate the creation of 3D models to scale up quickly, aren't you going to end up with glitchy, low-res machinery that breaks the immersion and ruins the safety training? How do they avoid that?
It's a very valid concern, and it's exactly why the batch generation pipeline is tied directly back to those rigorous quality gates we discussed earlier.
Oh, okay.
The pipeline is an AI-assisted engine that ingests data, whether that is CAD files from manufacturer or real-world photogrammetry, and standardizes it.
Got it.
It is a highly scalable system capable of rapidly generating hundreds and eventually millions of new 3D assets.
Yeah.
But the AI doesn't just spit out a finished model.
Right.
It pushes all of them through the exact same empirical gauntlet. It automatically checks the polygon count, the physics boundaries, the component awareness.
So it is scaling the speed of creation, but maintaining the human-level rigor of the validation.
Exactly. This means the library isn't static. It is going to continuously expand at an exponential rate, capturing more verticals, more specialized equipment, and more operational scenarios without sacrificing that vital operational realism.
That's amazing.
If a company invents a new type of robotic arm on a Monday, the CAD data can be fed into the batch generation pipeline, and a perfectly validated, component-aware, knowledge-injected 3D model can be in the Genesis 2.0 library almost immediately.
It is actively solving the time and cost bottleneck forever. It is effectively automating the creation of reality.
Beautifully put.
Which perfectly frames the broader vision behind all of this. There is a direct quote from Dan Lajerskar, the chairman of EONAI Ventures, in the launch release that I think sums up the magnitude of what they've built.
Oh, I know the quote. He says, "The launch of EON Genesis 2.0 represents a transformative moment for workforce development and immersive training globally. By delivering the world's largest validated 3D library tailored to real-world applications, we're breaking the barriers of time, cost, and scalability that have long hampered progress in this field."
Yeah.
He goes on to say, "This is the acceleration layer enterprises need to bridge operational readiness with the possibilities of AI-powered simulation."
The acceleration layer. That phrasing is so deliberate. It really highlights that this isn't just a software product, it's a foundational infrastructure for the future of work. It is all about accelerating that time to competency.
This raises an important question, doesn't it?
What's that?
If the bottleneck of content creation is truly broken, how fast will industries evolve once their training methodologies can actually outpace their physical innovations?
Oh, wow.
Historically, innovation has always had to wait for the workforce to catch up. If you can train a global workforce on a new piece of technology the exact same day the physical technology is finalized on the assembly line, The speed of industrial advancement is going to be absolutely staggering.
We won't be held back by our ability to learn.
Exactly.
It is incredibly empowering. So, to do a quick recap for everyone listening, today we are witnessing the move from a slow, incredibly expensive bespoke model of immersive training into a highly scalable, instant library-first model.
Yep.
EON Genesis 2.0 is packing 19 industry verticals with smart, interactive, knowledge-injected, and beautifully validated 3D assets. Businesses can use this as reusable training capital that plugs right into their existing hardware.
It's all there.
It removes the friction, it guarantees safety through empirical accuracy, and thanks to the batch generation pipeline, it is infinitely scalable.
It is the realization of what simulation-based training was always meant to be. It respects a learner's time and provides them with the absolute best tools to master their craft.
Think about your own field right now. Think about a wildly complex skill you have always wanted to learn, or a piece of software or machinery that took you months of frustrating trial and error to master on the job.
We all have one.
We really do. Imagine how a tool like the Genesis 2.0 library could have completely removed the friction of that learning curve. Imagine just putting on a headset and having the machine itself guide your hands, giving you hands-on, realistic experience instantly.
And as we look at where this is heading, especially with that mention of continuous expansion and AI-powered simulation, I want to leave you with a thought.
Okay.
Imagine a near future where every single piece of physical equipment manufactured in the real world, every commercial jet engine, every MRI machine, every logistics robot is simultaneously born with a fully annotated, component-aware 3D twin in this library.
Wow, just out of the box.
Yeah. It just becomes a standard part of manufacturing. What happens to our very concept of entry-level experience when anyone, anywhere in the world, can rack up hundreds of hours of perfectly simulated, AI-guided operational practice before they even walk through the door on their very first day?
It completely redefines what it means to be a beginner. When that happens, the fantasy we talked about at the very beginning, the instant download of complex skills, isn't a fantasy anymore.
Not at all.
You won't have to wait for the download, and you won't have to wait for the training module to be built. The simulation will already be waiting for you. Thank you so much for joining us on this deep dive into the EON Genesis 2.0 launch. We will catch you next time.